We see that the green boat is nearly in a straight line with Mark 1, while the blue boat is more to the left of it. The question is, who will reach Mark 1 first? Who has a shorter distance to sail? Assume both boats are sailing at the same speed and tacking equally well. If we asked someone who isn't very knowledgeable about sailing, they'd say the green boat is closer in a straight line distance, while the blue boat is further away because it's more to the left. But that's not how things work in sailing, because we don't sail directly toward the mark, we sail at an angle to the wind. We can't sail in a straight line toward a point, essentially zigzagging to reach our destination. So let's look at how far the blue and green boats sail to reach Mark 1. In the first leg, they both start from the same point, our starting line. They each travel 2 squares forward and then tack. Both then travel the same number of squares to the next point. So from that point to the next, they both have sailed the same distance, and each has done 1 tack. Now, looking above that line, we see the blue boat sails this light blue distance, and the green sails a wider green distance. This forms an isosceles triangle, meaning those 2 sides are of equal length. In simpler terms, those 2 distances are the same. So from this point to the next, both boats sail the same distance. Then from there to Mark 1, the orange path is common to both boats. So, in this example, both the green and blue boats have effectively sailed the same distance to reach Mark 1. They each performed 2 tacks and traveled the exact same total distance. What does this tell us? It tells us it doesn't matter if we're more to the left or more to the right of the mark, as long as we're within the ley lines. They start. We see them cross the line together, having sailed the same distance. As they head up to Mark 1, they are still the same distance from it. I am referring to the distance relative to the wind direction, not the direct straight line distance. We continue. We see that they reach Mark 1 at the same time. They sailed the same distance and performed the same maneuvers. Now that we've seen this, let's look at a simpler way to measure distance to a mark. The classic method in sailing is to draw parallel lines that are perpendicular to the wind direction. These are called ladder rungs, like steps on a ladder. They let us see how much closer or farther each boat is compared to the others. Now we'll see what happens if the wind shifts to the left or the right. In this example, up to this point the wind is steady. From here on, the wind shifts to the left. Let's see if and how much the blue boat, which is further left, benefits from the leftward shift compared to the green boat on the right. They start. Up to this point nothing changes. They are equally distant from Mark 1. Now the wind shifts. We rotate the image to immediately see the advantage. As soon as the wind shifts left, the blue boat is higher than the green, immediately closer to Mark 1. Continuing the animation, we see that the blue boat gained an advantage and arrives at Mark 1 earlier. It benefited from the wind shift. So we understand that if the blue boat knew the wind would shift to the left halfway up the course, it could choose to stay more left to take advantage. Indeed, the blue sailed more left and tacked near Mark 1 to benefit from the wind shift and gain an advantage.